All of the stuff you see here are video games you will be able to make after watching this video. Making games is becoming easier and easier, so you can literally make all 3 of these games today, even if you're a complete beginner, and I'm gonna show you how. First of all, we have to download Unity, so head over to unity3d.com, find the download button, which shouldn't be too hard. There are 3 different versions. We're gonna go with Personal because this version is free. Honestly, there's really no big difference between the 3 versions. As long as you're not making more than 100k per year with your games, that's pretty much the only restriction there is, but let's be real, we're not gonna hit that all that quickly. So hit download or try Personal or however the button is called. During the installation process, you will be able to choose which packages you want to install. Certainly doesn't hurt to check the following 5: Unity, documentation, Android build support, Linux build support, and WebGL build support, but honestly it doesn't really matter as long as Unity is checked, you're good. Install, install, install. This is the first thing you should see when you open Unity. Just press the magical work offline button. In case that doesn't work, you might just want to create a Unity account real quick. We want to make a new project, just call it First Game Experiments or something like that. Let's keep this on the default 3D, select a nice location, and just click on Create Project. This will take a couple of seconds. This is what you should see once Unity is open. The interface consists of multiple windows. You can drag these windows around if you want. For example, I could put that one over here, or I could put it back here. You can change the size of these. If you mess this up at any point in time, you can go to the top right here, where you can choose between different layouts. Just reselect default, and everything will be back to normal. Let's talk about what all of these windows do real quick. Down here is the project window, so basically the entire folder structure of your project. All of the resources, sounds, scripts, graphics your game has, everything comes in here. Here's where you can create new folders. And then when you click in Show Explorer, all of these folders really exist, so this is basically your project folder, and you can manage that right here from within Unity. This right here is the hierarchy window. Here you can see all of the objects that are currently in your scene. At the moment, that should only be the main camera and the directional light. If you double click one of these objects, the camera will move towards that in the scene. Just clicking once is enough to select it though. So we have one camera and one light. And then you can see whenever we select something over here in the inspector window, we can see all of the components and all of the scripts that are attached to that object. So here on the camera object, we have a transform. Every object in the scene has a transform because the transform just specifies the position, the rotation, and the scale of the object. And then the camera also has a camera component. So basically the camera script that is responsible for rendering and all that sort of stuff, and an audio listener. So the inspector window over here is just really for having a closer look at the selected object. This right here is obviously the scene view, so here you can see all of the objects you have in the scene. If you press the middle mouse button, you can move the camera around. If you press the right mouse button, you can turn the camera and look around. And also if you keep the right mouse button pressed, you can use W, A, S, and D to move the camera around, just like in a first-person game. If you press the Alt key, you can rotate the camera with the left mouse button. And you can zoom with the right mouse button, and you can still move the camera with the middle mouse button. Definitely make sure you get familiar with these camera controls right here, because you'll have to navigate around here quite a bit. Here we can see a little cube that shows us where the axes are. So this is the x-axis, z-axis, y-axis. By hitting that cube in the center right there, you can switch to isometric view. In case you don't know what isometric view is, this is a cube in perspective view. And this is a cube in isometric view. So all of the sides become equally long, and objects always have the same size no matter how far they are from the camera. You can toggle that on and off by clicking again. And you can also rotate the camera in 90-degree angles by clicking directly on the axis. There are 3 more windows right here. At the moment they are hidden. For one, down here is the console window. Here's where all of the errors and debug messages will appear. Once we have coded something, make sure all of these little icons here are pressed down, otherwise you won't be able to see warnings and errors. Make sure to check this window every once in a while, especially when something doesn't work as intended. Up here we have the game window. So this is how the game will look like. What's the difference between the game window and the scene window? Let me show you real quick. The game window basically just shows what the camera sees. So if we rotate the camera right here, for example, the game window changes. So this game window right here is what you will see once we hit the play button. And then we also have the asset store right here where you can download assets and scripts. We don't really need that at the moment. We can close that tab. Once again, if you accidentally close a window, you can bring it back here with Windows and finding the correct thing, or just once again clicking on the default layout and bringing everything back to normal. Now let me show you how you create a new object. To create a new object, we click on Game Object, and then either on Create Empty, so this will create a game object that just has a transform, and we can add behaviors and scripts ourselves. Or we can also create a game object that already has some stuff on it. We're gonna do that right now. We're gonna choose 3D object, cube. Now we have a cube in the scene. Try moving your camera around that a little bit, try to practice that, and then have a look over here. The cube has a transform component. We can change the coordinates here, or we can also change the coordinates in scene right here. If we want to move an object, you can choose between different modes. This mode is for moving the object. This mode is for rotating the object. This mode is for scaling the object. This mode is for scaling as well. And then this mode right here combines all of the handles, allows you to rotate, move, and scale the object. You can also create an object by right-clicking into the hierarchy and selecting either empty or whatever you want to create. Then here the mesh filter and the mesh renderer is really just for rendering the mesh. And then the box collider is so the object can collide with other objects. If it doesn't need to collide with other objects, you can remove that one. For now, we absolutely do want this to collide with other objects, so let's leave that in there. Also note that you can switch between different edit modes with W, E, and R. That should definitely go into muscle memory because that makes things a lot easier. W, E, R. Let's make that a little bigger so we can use it as a ground. Now if we look in our game view, we can already see the plane. Let's move the camera a little closer. Now if we click play, we can see this window right here. So at the moment the game is running, nothing's moving, so we don't see that the game's running. While the game is running, you can still do stuff, and this is actually pretty dangerous. For example, you can still move this around, make a lot of changes, edit your game. Same when the game is paused, you can still do all sorts of stuff. The only problem is, these changes are not permanent. You need to be very careful with this. Make sure you stop the play mode by pressing the play button again. And if you do that, you can see everything goes back to the place where it was when you started play mode. Do not, I can't stress that enough, do not make a lot of changes while play mode is enabled. All of that work will be for nothing, none of that will be saved. You can do so when you want to try stuff out. It's great for that because all of your changes will be reverted. But don't keep working on your game while the play mode is still enabled. In fact, I would advise you to go to Edit, Preferences, Colors, and then change this color, Play Mode Tint. Let's change that to red so we get a really clear and obvious warning sign when play mode is activated. Now if we hit play mode, everything will turn red. This way we know, okay, damn, I should not make any changes here. As I said, you still can still move all of that shit around. But once again, once you stop play mode, everything will go back to normal. Now let's make something that actually moves. Let's just create another cube. And to this cube, we're gonna add a new component, a new script, if you will. For that, we just select the cube if it's not selected and add component, this button right here, and then search for rigid body, BAP. This means this is a physics object. When we click play now, this cube will fall down. I know, not that spectacular, but now if we duplicate that object with Ctrl D, and create a couple more cubes, maybe stack them on top of each other like this. We already have a very nice physics simulation and we can see stuff moving on the screen. Very nice. So this is already something that's kind of fun to play around with. Cool. You can do the same with balls, by the way. Just create a new object, right click here, create sphere. Here we go. Now, this is basically flying, frozen in space. If we want this to fall down as well, we need to give it a rigid body. Not a rigid body 2D, because we're not making a 2D game, but a rigid body. So now this ball should fall down as well. Cool. Yes. If we add a couple more objects, this list will soon be pretty damn long, which is confusing. The way you clean this up is we just create a new empty object, call this however you want to call it, and then we can just put everything in there. Here we go, all of the cubes, for example. And this way it just looks a little more clean. You can open and close this like this. Really doesn't make a difference. Still looks exactly the same when you hit play. Just a little more clean. Also has the advantage that now you can move all of these objects at once. You can activate and deactivate them all at once. Basically every object has a little checkbox right here. With that you can activate and deactivate the entire object. And another cool thing I want to show you is this is also the way you can make these objects a little bigger and give them additional colliders. For example, I can duplicate the sphere and now I can drag this sphere into this sphere. Now all I need to do is remove the rigid body from this sphere, from sphere 1, from the child. So the objects inside these objects are called children. And obviously this here is called the parent. So only the parent needs the rigid body. But in here we can add a lot of cool stuff. We could even add another cube if we wanted. Let's do that. Nice. Now we have a weird worm-shaped thingy. Let's rename that to worm. And now we can duplicate that as well if we want. Maybe make a new folder here by creating an empty object. Making sure this is directly in the hierarchy. Then dragging all of our worms in there. Worms. Let's see how this looks in action. Hell yeah. Another pro tip, by the way, if you want this to be maximized whenever you hit the play button, just click maximize on play here in the games tab. And now when I click play, this will be a little bigger. Now, if you think this is still not clean enough, you could even create another object, call it something like physics objects and put your objects in there. So this is how you create these parent-child hierarchies that make handling and dealing with a huge amount of objects a lot easier. Now let's say you want to give your objects a different color. The way you do that is by right-clicking into the projects folder, create, and then material. Gonna call this one material 1. Now in the inspector you can see the material properties. The only thing we want to change right now is the albedo color. This is my reference. Just gonna pick this color. You can duplicate these with Control D as well. I want to have 5 of them, so I can just copy those colors here. Here we go. Now I selected some nice colors. Let's put all of these materials into a folder to just keep it clean. Let's call the folder materials, select all of these, drag them in there. Now you can basically just drag these materials on these objects. Or if you don't do that one by one, you can also just select all of them. For example, I can select all of the cubes. And then here in the mesh renderer, if you open materials, this slot right here, element 0, is where you drag in the material. And with that you can color all of these at once. Then we can give the ground a different color once again. Now let's select all of these objects in the worms. Make all of these yellow. Et voila, we have some colored objects. Hell yeah. You can see that there's already a folder in here. It's called scenes. And this is probably the scene you're in right now. If you double click that, you get asked if you want to save the current scene because this scene will be loaded. So yes, we want to save that scene. But actually this scene is exactly the same. So nothing changes when you double click it. If we create a new scene, here we go. We can rename it. So this could, for example, be a different level or a different part of the game. If you double tap that, we're in a completely different scene. All of the objects from the other scene are gone. We only have our camera and our light, but obviously you can go back to the old scene anytime. Here we go. Maybe we want to create an object in scene number 2. Voila. Now we obviously need to save that scene. For that we go to File, Save Scene. Also make sure to hit Save Project every once in a while. Best practice is probably just doing both, save scene and save project. Save scene really just saves the objects in the current scene. Save projects basically saves some project settings and objects that are here in the project folder. Save scene probably even a little more important though. Okay, let's get rid of all of this crap right here. Let's just keep the ground plane, make that even again by entering 0, 0, 0 into the rotation. Then I'm gonna create a new sphere. Give that a rigid body. And now let's write our very first script, and let's make a new folder for scripts. Don't worry about the prefabs folder, by the way, you didn't miss anything. I decided to cross that from the video because prefabs are going to get a pretty big overhaul sometime soon and we do not need them for the rest of the video. Then you right click into that folder, click create, and then you click C# script. Let's call it add constant velocity. Now if you double click that, a text editor will open. For you it's probably gonna be mono develop. For me, it's a Visual Studio. Doesn't make a huge difference for now. And this is what you should see. First thing you should check is that this string right here, this name right here, needs to be the same as this one, as the name of your file. Otherwise, you're gonna run into problems. So always check whether this string is the same as this one right here. Most of the stuff you see here is stuff we can ignore. The only two important portions are this one and this one. Use this for initialization. All of the code we write in here will be executed once at the beginning. Everything we write in here, update is called once per frame, will be called once per frame. So that's about 60 times per second, 100 times per second, depending on how fast the game renders. So this is not a fixed time interval, depends on how good your graphics card is, but this will be executed constantly. So far we didn't write anything in here. Anyway, we can still attach the script to objects just like these components right here. So you can find your own script, add constant velocity z. I could add that right here. If we click that small gear wheel, we can click remove component, then it's gone again. And another way to add it to your object is just to drag it on here. Here we go. So all of the things that are already on our sphere object right here are basically scripts that we didn't have to write ourselves, right? This one is one we're gonna write ourselves. In order to make our object move, we need to communicate with this script right here, with the rigid body. That's the script that handles all of the physics simulations. So we need to contact that script. The way we do that is we write get component. Then we make this weird bracket right here and write rigid body. Then you open and close a bracket. Don't worry about all of that too much yet. You'll get used to the syntax as you go. All you need to know for now is this returns the rigid body of this object. And now if we write dot, we can see all of the things we can do with that rigid body. All of the variables, all of the functions this object has. The one we are looking for is just the velocity. And the velocity is a vector, so the direction and the speed the rigid body is moving in. In case you're wondering how a vector looks like, a vector basically looks like that. It has an x component, a y component, and a z component. So this basically just sets the horizontal speed to 2, the vertical speed to 10, and then the speed in the z-axis to -6. So the z-axis is this blue one right here. The way that looks when we launch the game is nothing, because we need to save the script first. Now it's recompiling. Now if we click play, our ball flies away into this specified direction. So let's just try to make it move only into the x direction, okay? So we're gonna set y and z to 0. Now it should only move on the x-axis in theory. Let's see if that works. Yes, it does. But it's also not falling down anymore. And there is a very logical reason for that. It's because we're setting the velocity exactly to this vector. That means whenever our object starts falling down, this y velocity usually gets a lot higher, but we also reset it to 0, so it can't start falling down. What we can do about this is just changing this equal sign here to a plus equals. So whenever you write an equal sign in coding, that means we set this variable to this value. So the velocity of this rigid body will be overwritten with this vector. If we write a plus equal sign, that means we will add this value to this, meaning the x velocity will get 2 higher every single frame. That will obviously be a little too fast, so let's lower that to 0.1, and then we need to write an f to indicate that this is a float value. So whenever you have numbers like that contain a dot, probably need to write an f after that. There are different kinds of variable types, different kinds of numbers, and we just wanna tell the program that this is a normal float number, so that's why we need to write the f. Okay, now it's falling down again. Very nice. Now putting that into the update function is a little risky because we do not know how often the update function is called. So if our game is running faster, the ball also speeds up faster, because every time a frame is rendered, we add something to the speed. That is obviously a problem. So your game will basically run faster on faster machines. That's not what we want at all. So what we'll do for now is, instead of coding everything into the update function here, is coding everything into the fixed update function. And fixed update is called exactly 100 times per second. We can rely on the fact that this will always run with the same speed. It's always good to code physics stuff into the fixed update function. Now what we want to do is creating a little settings window right here where we can specify the speed of this object. We want to be able to change this right in the editor. We don't want to go into the script every time we want to change the speed of this. So let's just write vector3. So this tells the program which kind of variable we want to have. And now let's name our vector. You can name that whatever the hell you want, but usually it's a good idea to have a little indicator at the beginning of the variable which kind of variable this is, so you can see that more easily later on. I'm gonna call this v3 force, then just make a semicolon. Never forget to make the semicolon at the end of the line. I forgot to mention that earlier. Here needs to be a semicolon, of course. If we want that to be modifiable from the editor, we need to make these brackets right here and write serialize field. This serialize field attribute will apply to this variable. Now if we go into the editor, we can see our variable appears right here, and we can modify the variable right here in the editor. Now all we need to do is replace this vector down here with our new custom vector that we can modify from the editor. We don't need the start event, so we can delete that, clean this up a bit. Here we go. So this is our very first script. All it does, it just applies a constant force to your object, and you can change that force right here in the editor. So let's make a couple of experiments if this works. Let's, for example, set the force to 0.1. Here we go. Goes to the right. Now let's set it to minus 0.05. Now it should go to the left. Perfect. Enter 0.2. Yes, it's able to overcome gravity. Now it's going upwards. And all of that obviously also works in the z-axis. Perfect. Our first script is hereby done. Next thing I want to do is make the sphere controlled by the player. For that we're gonna need a new script. Let's just duplicate the one we already have. Let's rename that to add player controlled velocity. Then I'm gonna copy that name and double click that, so now it's open here. And then remember to replace this with add player controlled velocity, so it has the same name as the file. And now I just want to add 2 more serialized variables, 2 more of these serialized field. This time the variable type is key code, so a button. Let's call this one key positive. Let's duplicate that and call this one negative. Now if you save that script, let's remove that component and add this component, add player controlled velocity. We should have a force vector right here. And then we should be able to choose a positive key and a negative key. And now the way I imagine this will work is I can say I want this object to move on the x-axis. So I'm gonna put a 1 here. Then we could, for example, choose, let's choose right arrow for positive, and then let's go with left arrow. Obviously this doesn't do anything yet. What I want to do now is just add a new if statement. If statement looks like this. You write if. Then you open a bracket and you close a bracket, input dot get key. Then we open another bracket and close another bracket, and in those brackets we write our variable key positive. Then go 1 line down here, press tab. Here we go. So now this force is only added if we press the positive button. Let's do the same with the negative button. Only difference, when we press the negative button, we don't want to add the force. We want to subtract the force. This way we can move in both directions. Very simple script. Should work out just fine. Let's give it a go. Alright, it's a little fast, but I can now control the ball to the left and to the right. Let's make it a little slower. 0.2. Yeah, that feels nice. Obviously, you can also use a different axis, the z-axis, for example. Now we move diagonally. If we move the x component of this vector, we're just gonna move vertically. So basically, if I want this ball to be controllable in all directions, what do we need to do? We're just gonna keep it like this, and actually can add multiple of these components onto one object. So that's exactly what we're gonna do. Just add this one more time and do the same thing for the C component. And then select the according buttons on the keyboard, up arrow positive, down arrow for negative. So now we have the X movement and the C movement. Now I can move my ball in all directions. Hell yeah. So I'd say it's time to build the first small level, cause why the hell not? This tutorial is all about experimenting and having fun, so feel free to mess around with this stuff as well. Okay, now let's adjust the camera so it can see everything that's going on. Let's see if getting up here is possible. Okay. Jabba-ju. Next up, I want there to be a way to restart the level, because at the moment, if I mess up, the only way I can restart is by pausing the game and pressing play again. That's a little annoying, so let's make a restart button real quick. For that, let's just make a new script and let's call it restart level with button. All we need is a serialized field with a key code. Let's call it key restart. We don't need the start event. Cleaning this up a little bit. By the way, whenever you make 2 slashes like this, you can write a comment. This will not affect the code at all after 2 slashes. So you can delete that sort of stuff, no problem at all. Now, how do we check if the button is pressed? We just, once again, ask if input dot get key restart. Now, if all of this is true, if the button is pressed, then we want to restart the scene. For this, we actually need to add something up here using Unity engine dot scene management and then a semicolon. So this is just a package of scripts we can use, and the scripts we want to use happen to be in this package and not in those 3 packages. So we just need to add another one. Now we can write scene manager dot load scene, open bracket, close bracket. And then we want to load the scene we're in right now. The scene we want to load goes in here. So usually your text editor should show you what you need to write into those brackets. Sometimes you can write different things in there. You can switch between different versions by clicking on these arrows right here. We're gonna go for the string. So which scene do we want to load? Scene manager dot get active scene returns the scene we're in right now. Problem is this function doesn't take scenes as an input. Putting a scene in here is not an option, so we need to add dot name. This way we have an acceptable input for this function. Basically everything that has these brackets after it is a function, by the way. Okay, that's the script. Let's save it. And we can put that either on the sphere. I'm just gonna put it onto the camera because we only have one of these. You know what? If you wanna keep it super clean, just make a new object, a new empty object, and call it something like game manager, and then let's add our restart level with button script onto that. I want to be able to restart the level with the button R. Here we go. Save scene. So now whenever we hit R, level is restarted. Next up, I want the camera to follow our little sphere here so we can build bigger levels. One of the easiest ways to do that is just to align that to the ball somewhat properly, and then take the camera in the hierarchy and drag it into the sphere. Also, let's rename the sphere to player. Now the camera will follow the sphere. There's only one problem, and you'll see that. It basically also follows the rotation. Oh my god, this is horrible to look at. So there is a somewhat easy fix to this. If you click on the player on your sphere, take the rigid body component, you can see this one has some settings here as well. If you open this down here, constraints, we can just freeze the rotation. So this object is no longer allowed to rotate. This way our ball doesn't rotate and our camera doesn't rotate either. The problem being the ball doesn't rotate anymore. So if we want the ball to rotate, we need to find a different solution. And for that, we can just write a simple script. Let's call the script copy position. And we can write that right into the update event right here. We don't need the fixed update even for that. Fixed update is only useful for physics-based stuff. For this one, it's totally fine if it's just called whenever the frame is rendered. All we want to do is copy the position of an object. So we're going to write serialize field. And then the variable type we want to have this time is a transform. I'm going to call this trans target. Let's add that script right here. Now I can drag the player object in here, and we will automatically get the transform component of this object. So you see, this player object has a transform. The transform is the one that stores the position, the rotation, and the scale. And on our camera, we now have the reference to that transform. Meaning we can now say transform.position equals trans target.position. Transform obviously is the transform of this object. Trans target is the transform of our target object. So we will just copy the position of the target object. Very simple script. We're already done. Now there's a little bit of a problem with that. I'm gonna show you. If we hit play now, the camera is obviously inside the ball because we're exactly at the position of the ball. In order to fix that, we're gonna create an empty object, put that at the same position as the player. Here we go. Let's call this camera rig. And then let's drag the camera inside our camera rig. The camera rig really just at the moment is an empty object. Then we can remove the copy position script from the camera and put it on our camera rig instead. Then once again, we obviously need to get the reference to the player transform in there. And now this object right here, the camera rig, will always be placed where the player is, and that means the camera will always be at a position that makes sense, because see, if I move this camera rig right here, the camera moves along with it. If this camera rig follows the ball, then so does the camera. Now we can obviously unlock the rotation of the rigid body. We can allow this ball to rotate again, and now we are able to build a much larger level if we want. So let's do exactly that. Here we go. Let's hit play. Okay, haha, I did it! Next up, let's make the game restart automatically when the player falls down. There's really no point in not doing that. Let's just make a big surface down here. Here we go. So let's duplicate our restart level on button script, and let's call it restart level on collision. Now, remember, we need to change the name here as well. We don't need that key. What we need is a different event, because this is not supposed to happen every single frame. This is only supposed to happen whenever this object touches another object. So we need void on collision enter. And then we just put our scene restart script in there and delete all of the rest. Here we go. Let's save that. Now if we put that very script onto our lava ground right here, restart level on collision. Now whenever we touch that ground, the level should restart. In fact, it works. Haha, that's fantastic. There's one problem though. If I add another cube here, and let's give that cube a rigid body. If this cube touches the ground, I lose as well. So this is not exactly what we want. So how can we differentiate between those two objects? There's a very simple system for that in Unity that helps us out with that. Let's give this a new tag. Oh, there already is a player tag, so we could use that one, but we could also create a new tag by clicking on add tag, and then creating a new tag right here. So we're just gonna go with the custom player tag. Here we go. And then to our restart on collision script, add a new variable, serialize field, string. So string is basically text, call it string tag. And then we only reload the scene if collision.collider.tag equals the tag we want to check. Only then we restart the scene. Here in this very first line of these events, these functions, you can see which inputs this function has. So this entire thing is a function as well, and it has this input, collision, and we can use that input in here. So collision in this case is just some information about the object that touched us, about how we collided exactly, and it also happens to contain the tag of the object that we hit. So we can check that right here. if it's the correct tag, we're gonna restart the scene. Now let's say this one checks for the tag player. This one doesn't have the tag player. This object right here does have the tag player. So now pushing that box down there shouldn't do anything, but falling down there myself will restart the level. Great!
Time to build something awesome.
Alright, I took some more time to finish this level up. Just continued building some level design elements back here. Also, I added these stripes to the ball, which are parented spheres. See, basically just a flat sphere that is a child of this sphere. And I also removed the collider of it. I really just want those stripes to be optical, nothing that interferes with the gameplay. And also another big thing I did is I added some post-processing to the camera. You can see that here. This is how it looks without post-processing. This is how it looks with post-processing. Just looks a little bit nicer, but that's something we'll have to save for the next tutorial. For now, let's export this. For that, click on File, Build Settings. Then make sure your scene is in here. Scenes that you want to be included in the build, just drag them in here. You can also disable them like this. At the moment, there's no way to go to the second scene anyway, so everything's fine. And then let's just click on Build and Run, and that should build and run our game. We also need to specify a build location. For that, I'm just gonna go with the desktop for now. Then we'll have to wait for a second. Here we go. If the build is complete and you launch the game, you will see this window. Just click on Play, and we can play our game. Here's one issue you might run into if you make multiple scenes. When the level restarts, it suddenly looks way darker. The way to fix that is just to go to Windows, Rendering, Lighting Settings, then uncheck this Auto-Generate button and just click on Generate Lighting. That will take a second. When that is done, this issue shouldn't occur anymore when restarting the scene. Here we go. Problem solved. So here we have another game I made using the exact same scripts. It's a 1v1 game. You can play against your friends. One player controls with the arrow keys, one player controls with WASD. Whoever pushes the other one off the platform wins, and the game just restarts. So I challenge you to make this game as well. You don't need to write any new scripts for this. It's a good exercise. Try to make this game. Here's something completely different, but still using the same script, so you don't need to write any new scripts for this. The goal is basically to get this block out of there, and you can move the purple blocks left and right, and you can move the orange blocks up and down. So yeah, you've just gotta be creative. There's already a lot you can do with this, and I challenge you to build this game as well. A little trick you need to know is you can change the camera perspective between orthographic and perspective on the camera. For this really cool casual look, you just need to turn it to orthographic. Remember that you can freeze the position and the rotation of a rigid body on certain axes. In the settings of the rigid body, that is definitely useful for that. Other than that, you should absolutely be able to create this without creating any new scripts. In the next tutorial, we'll expand on all of that even further. Writing more cool scripts you can play around with, bringing enemies into the game, making games that have multiple levels. But for now, I'm really happy I managed to get you to a place where you can start experimenting yourself. There are already so many creative things you can do with the scripts we have so far. What if the player could control multiple objects at once, for example? You could make a co-op puzzle game where player A is only allowed to touch blue blocks and player B is only allowed to touch green blocks. Maybe you can't control the player directly. Maybe you can only control objects in the level. You could build a giant labyrinth or a massive collapsible castle out of rigid bodies. Be creative, and the joy of game development starts now.